Math 1314, Tyler Junior College, Section 4.1, Exponential Functions. The natural base, E. Trying to figure out the most natural way to approach this, but due to the train wreck at the end of the previous video, we'll just jump right into it. As x approaches infinity, meaning that x gets larger and larger, the expression 1 plus 1 over x to the x power actually approaches a specific value. And there's a lot of places in nature where if you model natural phenomenon using algebra, this expression arises and the x gets larger and larger. There's another equivalent to it where something gets closer to 0. Well, I guess I can show you real quick. Another version of it is x approaches 0 and you look at the expression 1 plus x to the 1 over x power. Basically everything got reciprocated. Reciprocate this, it becomes 0, so to speak. Reciprocate this, reciprocate that. But the point is, both of these expressions occur all over the place in natural phenomena. And when you take the value as x approaches infinity here, or in the other version as x approaches 0, you have this battle between two values. The inside of the parentheses starts getting closer and closer to 1, and that's pretty easy to see. When the x gets really large, this fraction becomes the reciprocal of a really large number, which is a really small number. So the larger the x, the smaller the fraction. This fraction gets closer and closer to 0. So adding it to 1 means that this base gets closer and closer to 1. However, the exponent gets larger and larger and larger. 1 to any power, of course, is equal to 1. But as the powers gets larger, for bases greater than 1, then I know what I'm trying to say. Let's just put it this way. If I put in x equals 1, I get 1 plus 1 is 2 to the first power. If I put in x equals 2, I get 1 plus 1 half, which is 1.5, to the second power. If I put in x equals, let's use 4 because 1/4 is just 0.25. If I put in 4, 1 plus 1/4 is 1.25, then it gets raised to the fourth power. If I put in 10, this becomes 1 plus 1/10, which is 1.1 to the 10th power. What I'm saying is we have this battle going on. This base is getting closer and closer to 1. And of course, 1 to any number makes, 1 to any power is equal to 1. Or more generically, as the base gets smaller, so does the value, but the exponent is getting larger. So who's going to win this battle? The base is getting smaller and closer to 1, or the exponent is getting larger? And the truth is, it's kind of a draw, that the values of this start settling on a specific value, and that value has a special name. It's called E. I'm going to introduce a little bit of calculus lingo to you. It's called limit. That's what the LIM stands for. It's basically the calculus way of saying things that we've been saying all along. What happens to this as x approaches that? In other words, the limit as x approaches infinity of this expression. It actually settles down to a number that's called E. Now, if you're wondering what E is, I can tell you what it is. In fact, I'll do it over here. I can't tell you exactly what it is because E is kind of like pi. It's a decimal that goes forever and never repeats. But if I wanted to know its value, I can tell you that it's about 2.71828.459045. Now, you're not going to have to memorize this. I just happen to have that much of it memorized. I know it starts 2.7, and then the next 4 look like a year, 1828, and it must have been an important year because it shows it twice. And then if you've ever had trigonometry or geometry, you might recognize these as the angles in an isosceles right triangle. But that aside, it's a number, and it's about 2.72 if you will, if you rounded it to 2 decimal places. So what are you going to have to do with the number E? And I did say the number E. Well, one thing you'll have to be able to do is evaluate it to certain powers. For example, let's say I ask you what e to the second power is equal to. Well, the nice thing is you don't have to remember the value of e because your calculator should know it. I'm going to go to the other side of the camera so that I can hold the calculator up here and show you how to use it to evaluate e to certain powers. Now, there are two types of calculators, display and one line. A display calculator displays problems as you type them. So for example, if I, well, first I have to turn the calculator on, hold on. For example, if I typed 2 plus 3, then it's going to display 2 plus 3. When I press enter, it'll give me a value of 5. Now, if you have a display calculator, it might be a graphing calculator, it might be this one, it might be a different one. But regardless, it probably has a button on it that says LN or E. This one has E with a little square. Now, this is a kind of an obscure calculator, but if you have a display calculator, it's going to work pretty much the same. If you want to raise E to a power, you have to find the button that says E to a power. I'll admit that on many calculators, it's above another button like this one. It's above the button that says LN where it says E to the X. But I'm going to use this one to show you how to use it in a different calculator in a moment. But you're responsible for having a calculator with an E to a power button and knowing where to find it. This one, you just press it and it says that. And then you can put in the exponent of your choice like 2, press enter, and it will give you a decimal approximation of about 7 point however many decimals you want. Now, that's a display calculator, a calculator that displays the problem as you type it. However, you may have what I call a one-line calculator. A one-line calculator is precisely that. It has one line of numbers. Can't show you the problem you typed in. All it can show you is the last answer it calculated or the last number you typed. If you have a one-line calculator, your E to a power button is probably above a button that says LN. And because it's above it, you'll probably have to press something like second or shift to access it. But here's the important difference. In a one-line calculator, you have to put the exponent in before you press the E to a power button. So if I wanted to do E to the second power on here, I would first have to press 2. Then I would have to say second E to that power, and it gives me the same answer as before. So it is your responsibility to have a calculator with an E button on it and know how to use it. If you have such a calculator and you don't know how to use it, please contact me. If you're in my class, you can text me. If you're some random person watching this YouTube video, send me a message through YouTube and I'll do my best to help you out. But raising E to a power is pretty easy, and it's going to show up in some of the things that we do, not just in this section, but later on in this chapter as well.